Assalamualaikum warahmatullahi wabarakatuh and very good day to Doctor. My name is Muhammad Aimran183804 bin Muhammad Azhar. My metric number is 183804. My final year project title is Selective Study of Ester type polyurethane based intumescent and ether type polyurethane coating. My supervisor for this project is Associate Professor Dr. Muhammad Halim Shah bin Ismail. For the introduction, nowadays, the various functions of synthetic polymer offer society in modern life. The class of polymers known as the polyurethane now comprises a wide variety of material ranging from surface coating. In these studies, the polyurethane was used as the fire insulation and also the water-resistant coating. There are two types of polyurethane which are ether-based and ester-based of polyurethane. However, these two types of PU will give different characteristics towards the water-resistant coating. Next, the intumescent in the coating act as the thermal insulation application, and the addition of fluorocarbon surfactant in the PU binder gives the anti-flame surface of the coating. Comes to objective section. This study was carried out to investigate the effectiveness of the fire and water resistance of the formulated polyurethane intumescent coating with different coating additives which are ether-based polyurethane binder and fluorocarbon surfactant. The objectives of these studies are: first, to investigate the performance of formulated polyurethane intumescent coating in thermal and physical behavior. Second, to determine the outcomes of different types of ether-based polyurethane binder towards as the water-resistant coating. Third, to determine the effect of the addition of fluorocarbon surfactant in the ether-based polyurethane binder towards the anti-flame spray application. Finally, to determine the morphology of the coating surface effect due to the different timing for curing. For assumption and hypothesis for this study, first, this study was expected that the specimen be able to withstand around 1000 to 1100 degrees C of butane torch in more than 60 minutes without any penetration through the specimen. Second, the temperature of the specimen was expected to be increased very low. Third, the coated material be able to withstand water immersion more than 24 hours without losing its flame retardancy. Finally, the coated material can slow down the flame spreading of the coating during fire tests. Comes to literature review section. Polyurethane, the one feature common to all PUs in the urethane linkage, which is formed by reaction of hydroxy group with an isocyanate group. However, the urethane linkage is not the only linking group in the structure, but other includes the ester and ether type link present in PU precursor. Although the flammability of PU might be expected to be lower than those of many other polymers due to their significant nitrogen content and the cross-linking usually present. Due to the high product surface area, especially in foams, the fire performance of PU-based materials are often poor. According to Joseph and Edmund, it is designed to improve the flame retardant of PU foams. There are two types of polyurethane. First, ester-based polyurethane. Ester-based polyurethane was slightly more rigid supportive compared to the ether relative. The shock absorption that produced out of the ester form give the result in excellent packaging qualities, lend it to being treated with agents to create the pink anti-static forms that dissipated the electrostatic charge in sensitive electronic equipment on instrument. Next, the ether-based polyurethane. Ether-based polyurethane are more flexible and better in wet environment. It has large cell structure compared to ester-based polyurethane, which allow greater airflow and moisture permeability. Ether-based PU has better moisture resistance against hydrolysis, the breakdown of molecule in contact with water. In conclusion, the ether-based polyurethane were more water-resistant characteristic compared to ester-based polyurethane. For intumescent, intumescent can be described as fire retardant technology which causes an otherwise flammable material to form, forming and insulating barriers when exposed to heat. A common characteristic of intumescent materials is that heat exposure initiates a chemical process that makes the material intumescent. It is the intumescent and porous part of the material which gives the insulation effect. According to Van der Sar and Flame, solidification into a thick multicellular char provides an insulating layer that slows down the transport of heat and reduces the amount of material that becomes involved in the fire. Come to the methodology part. Preparation of the formulated polyurethane intumescent coating. The optimum weight ratio of intumescent powder, the ester-based polyurethane binder, and distilled water is 6.25 to 1 to 4. It was mixed homogeneously by using the mortar for about 20 minutes until it looked like mucus and more viscous. After the solution was done, pour and spread the coating on the surface of the specimen and let it curing in the room condition. For characterization of forming agent analysis, there are 6 samples were prepared for this analysis. 5 samples are for scanning electron microscopy test and another 1 sample is for Fourier transform infrared spectroscopy. The morphology of specimen surface was determined at amplification of 300 and 3000 in SEM analysis. For FTIR analysis, considering the optimal level achieved, the formulated polyurethane intumescent coating was tested for FTIR spectroscopy in order to identify the functional group existing in the compound. Fire resistance test. Fire test is conducted to evaluate the penetration of fire to state substrate according to STM E119 and follow according to UL1709 in 3rd edition. The fire resistance test was performed by using blowtorch and thermocouple. As we can see, the picture, the setup was like the figure show. First, coat the specimen with formulated PU intumescent. The average thickness of the coating is around 0.73 mm. It's curing for 14 days, and after that, torch the specimen using the butane torch and record the time taken for the fire penetrate through the specimen. Repeat it by using cardboard without coating as the control specimen. For water immersion test, the average thickness of the ether-based PU binder is around 0.41 mm. First, coat the specimen with ether-based PU binder using paintbrush, then curing for 5 days. Next, half immerse the specimen in distilled water for 24 hours like figure show, then observe the physical properties change. Repeat it by using the same method by different method of coating, which is pouring and spreading. For anti-flame test, this anti-flame test is to study the surface fire spread of the ether-based polyurethane binder coating. The setup was same as the fire test. First, coat the specimen with addition of 1% fluorocarbon surfactant in 602T PU binder. The average thickness of the coating is around 0.23 mm. Curing it for 5 days in room condition, then torch the specimen for 10 seconds using butane torch, then observe the fire spread on the specimen surface. Repeat by using the same method, but the coating is without fluorocarbon. Comes to result and discussion. Optimization curing time with mass of coating. The mass of coating that start to be constant is at day 5. It can be concluded that the best day of formulated PU intumescent coating for curing is at day 5. Then for the minimum curing time is at day 3. This minimum curing time can be used in next experiment, which is water immersion test. This is because at the minimum time of curing, the coating is ready to be used for other experiment without changing its characteristic. They are losing some weights because due to the moisture loss. For SEM analysis, the particle were irregular in shape like crystalline form including some porous formation. Observing under 3000 of magnification, the particle were clearly observed that the longer the time of curing, the less void space between the particles. Micro cracks, which are believed to be shrinkage cracks, were clearly observed on the surface of the sample due probably to water evaporating during curing process. Comes to FTIR analysis, the formation of urethane binding curing process at 3326.73 wavelength, the existence of peak at 1543.29 wavelength shows that the presence of relative intensities of characteristic stretching band attributed to NH. Based on the FTIR result, it was proven that the coating produced was polyurethane based. For fire resistant test, based on the result, the temperature start to rise immediately at 20 minutes. This is probably due to the structure failure of intumescent char upon the strong punching force generated by the fast discharge combusting butane gas. Structure failure of intumescent char will cause char becomes thinner and broken in short time and thus losing its thermal protection ability. More gentle heating methods such as thermal radiation should be considered for future research to further investigate the thermal insulation property of the current PU-based intumescent. The char produced on the surface of the coating after resistance test is due to the intumescent effect. In water immersion test, the amount of bubble on the surface 60T were very least compared to others. 200A does not show any water resistant characteristic. This is because The polymolecules are not so hydrophilic and have less polarity, so that the chemical bond between the formulated Pu intermediate substrate surface and 200A was not strong, and the polymolecules intend to shrink and gather together to minimize the intersurface energy and causing crack. Best method to coat the specimen is by pouring and spread it on the surface instead using the paintbrush. This is because due to the distribution of the coating equally on the surface, this can cause some holes or voids produced on the surface that water can penetrate through the ether based PU binder coating and then reduce the performance of coating as water resistance. In anti-flame test, based on the figure A, the fire was splashed out and it spread rapidly on the surface as soon as the torch was removed compared with figure B. This is because the presence of fluorocarbon surfactant will inhibit the fire spread on the coating. C0T coating without fluorocarbon surfactant does not show any positive result on the anti-flame spread application. This is because the fluorocarbon surfactant has anti-combustion effect, which is better for the anti-flame spread application. With the addition of fluorocarbon surfactant, it will enhance the performance of the fire retardant coating and give more time before the material getting burned. Comes to conclusion. The optimum weight ratio of the formulated intumescent powder, ester-based polyurethane binder, and distilled water was 6.25 to 1:4. The average thickness of PU-based intumescent coating, either based PU binder coating, and FCS coating was 0.73 mm, 0.41, 0.23 mm respectively. SEM analysis on the morphology of the coating behavior have shown that the longer the time of curing for the coating led to the less number of voids between particles. The performance of formulated PU intermediate coating was determined by fire resistance test. The time taken for the fire start to penetrate through the specimen is about 13 minutes and 5 seconds. This is probably due to the structure failure of intumescent char upon the strong punching force generated by the fast discharge combusting butane gas. The best or either best binder as additive on the formulated PU intermediate coating was 602T. The result clearly observed after water immersion test. The amount of bubble on the surface very least compared to 200A and 501T binder. The addition of 1% of fluorocarbon surfactant in the C02T binder proved that it was inhibit the fire spread on the coating compared the 602T without addition to fluorocarbon. This is because the fluorocarbon surfactant has anti-combustion effect, which is better in anti-flame spread application. Numerous potential enhancements were recognized in the development of this study that could improve on coating development. The following are suggested for upcoming research. First, to use the spraying method in order to coat the specimen without any voids formed. Second, to conduct the fire resistance test with different type of curing in order to determine the minimum type of curing that needed for the best result. Third, to conduct other tests on the coating for potential application in chemical industry. That's all from me. Thank you very much.